Hello and welcome dear learners to the NPTEL course on nutritional epidemiology, a way towards a healthy life. For the module 3 dietary assessment, nutrition status and measurement error, for the chapter 31 we will be talking about anthropometric measurements. So here in this chapter we will be discussing about anthropometric measurements, its indicator, the growth charts and standards, the population versus individual assessment, advanced techniques of anthropometry, the obesity paradox in epidemiological studies, and also few case discussions will be taken. So what is anthropometry? As you all know, anthropometry is very important in epidemiological studies, and anthropometry refers to the systematic measurements of the physical dimensions and compositions of human body. So this term anthropometry originated from Greek words where anthropos means human and metron means measure. So it's a measurement of human. So the measurements are among the oldest and the most widely used tools in the nutritional assessment. So you must be knowing that it is very non-invasive, it is relatively inexpensive, easy to perform and suitable for large scale population studies. So that's the reason it is widely popular. The importance of anthropometric measurement lies in nutrition studies, especially in undernutrition, overnutrition, growth failure, and obesity. Monitoring growth and development, particularly for infants, children, and adolescents, it plays very important role. For estimation of body composition, particularly fat mass, lean body mass, and central adiposity, it takes more benefits actually to estimate this. It is also important in evaluation of public health programs, particularly ICDS program, midday meal, Poshan Abhiyan, and maternal nutrition programs. It is also benefiting in predictive disease risk, especially for anthropometric indicators that are associated with type 2 diabetes, hypertension, cardiovascular diseases, metabolic syndrome, and certain cancers. So if we do talk about the classification of the anthropometric measures, there are very traditional ways, derived indicators, and advanced measures. If I have to talk about the traditional measures, it is weight, height, length, mid upper arm circumference, that is called as MUAC, waist circumference, hip circumference, and skin fold thickness. To take the derived indicators, we have BMI. BMI is called as body mass index. Waist to hip ratio, waist to height ratio, and body fat percentage. These are very important indicators to point towards the measurement of anthropometry. Then comes advanced measures, that is called as DXA, that is dual energy X-ray absorptiometry. Then there is POD, air displacement flowmetric, and BIA, that is bioelectrical impedance analysis. So DXA and POD and BIA are something which are very advanced measures which are being taken more priority in the coming days. But what are the common anthropometric measurements? If we do talk about the traditional common methods, weighing comes very importantly, which calibrates the weight scale. Height is something which is giving you a measure by a standometer. Length, particularly in children's, infants, neonates, they are measured in a recumbent position for infants. The MUAC is something which is measuring your midpoint between the shoulder and the elbow. There is a small sort of strip which can be used as a form to measure this. The waist circumference is measured by a tape measuring at the midpoint between the lower rib and the iliac crest. The hip circumference is measured at the widest part of the buttocks. So what do you mean to start over here? At the next is the skin fold thickness, that is of the tricep muscles. It measures the subcutaneous fat using a calipers, which is demonstrated into the picture like this. The skin fold thickness of subscapular is measured by subcutaneous fat below the shoulder blade. All this is used across the life course. It can be used in infants, children, adults, and older adults also. What are the indicators of anthropometric measurements? Especially when I talk about BMI, the body mass index, it is a weight for height index. So what is a weight for height? The index is being calculated to classify the nutritional status in adults. The formula for BMI is very much stated, where you take the weight in kgs and you divide it by height square, that is meter square. Where versus when the height is being taken in meter, you have to put it up square and you divide it by for the 8. So when a weight is being calculated, you have to divide it by height square. Now we will see the classification of BMI in Asian specific and WHO as a global specific. For a global specific BMI, the classification is if the BMI is calculated 18.5 and lesser, it is underweight. If the BMI is between 18.5 to 24.9, it is normal. And when it is above 25 and below 29.9, it is overweight. And when it is above 30, as in calculation, it is obesity. So you can classically understand over here how the classification of underweight to obesity comes with WHO scale. With respect to Asia specific BMI cutoffs, we have this because these are developed according to the metabolic complications which are ruled out at the lower BMI level. Where here the BMI is 18.5 lower, it is underweight as usual, and 18.5 to 22.9 it is normal, and when you have it like 23 to 24.9, that till 25 it is overweight, and above 25 it is obese. Okay, so here there is a difference actually which is being seen from the WHO classification and Asian specific. What are the advantages of taking BMI? BMI is easy to calculate, it is very inexpensive, suitable for surveillance level, and so it is widely being used and very useful in epidemiological studies. But there are few limitations which I want to highlight over here. It is like it is a fat mass. Whatever you calculate is a fat mass. Then it is a muscle mass and a bone mass. So there are three levels of mass which cannot be distinguished. So BMI cannot distinguish between a fat mass, a muscle mass and bone mass. Okay. For example, a bodybuilder and a sedentary individual may have identical BMI value but very different in the body composition. So you may have an individual who may have a BMI identical to a person who is going to gym, but if you see the structure, it is completely different. So, but what are the epidemiological advantage for the purpose that we are doing the BMI? It is like it is widely used in cohort studies, national level nutrition surveys, global burden of disease analysis. It is very important, and especially in NCD surveillance systems, which makes to point out the difference of BMI with respect to the growing burden of non-communicable diseases. Now we will concentrate on waist circumference. Waist circumference measures the abdominal or central adipose. The reason of this is more pointing towards a central obesity. Central obesity is more strongly associated with metabolic diseases than the overall obesity. The reason is that if you have a central obesity, it is having more concentration towards the metabolic diseases. How do we measure? The measurement procedure lies to go with the lowest rib margin and the iliac crest. So as it is pointed over here, it is more to see that the lowest rib is being taken as a thing and the iliac crest over here. So you have to take the standing position. The person should be end of the normal expiration when you have finished the expiration, and flexible non-stretch step. So what you need to do, it is that it recommends actually that the measurement should be done fair into this procedure. It is indicated into the picture that here it is the lowest rib margin and the iliac crest. So here you have to take the measurement, it should be fitting and it should come over here. Okay, what is the recommended cutoff in South Asian countries? Especially for men, it is taken as above 90 centimeter, and for women it is above 80 centimeter. Why waist circumference matters? Because the visceral fat is associated with insulin resistance, the hypertension, dyslipidemia and cardiovascular disease. So it is very important that if it is going above, then it is more pointing towards your waist circumference, towards the central obesity. Okay, what are the strength? The strength is, it is very simple to measure. It has low cost and better predictor of metabolic risk than BMI alone. So along with BMI you can take this, but there are limitations. Regular requires a very standardized protocol, as it is mentioned the specification, and observer variation may differ to give some differences, and difference among ethnic groups. Okay, so the waist circumference is a very simple and a very practical measure of central obesity and a stronger predictor of metabolic risk rather than a BMI alone. Okay, so now we will concentrate on the skin fold thickness. The skin fold thickness estimates the subcutaneous fat stores. That measurements are taken usually by specialized calipers, where the common sites are triceps, which are being shown over here, then comes the biceps, then the scapular and suprailiac. Okay. In additional sites you may have abdomen, you may have thigh, and you may have the chest. Oh, okay. So the reason of doing this, that the procedure will pinch skin and subcutaneous fat, apply the caliper over here, read after 2 to 3 seconds and record the nearest 0.1 millimeter. The reason is like how the skin fold is again going back to its position after using the caliper. The estimation of the body fat, the skin fold measurement can be converted into body density, percent body fat using prediction equations. The advantage of doing skin fold thickness is like it is portable, relatively inexpensive and useful in field studies. The limitations is like it requires extensive training, large in observable variability and less accurate in severe obesity. The skin fold thickness is useful for estimating body fat in population, but requires skills, standardization and quality control for reliable results. Now we will talk about growth charts and standards. So why do we require growth assessment and how does it really matters, especially in children? So children should not only survive but also grow optimally. So the growth assessment of children is identified with respect to stunting, wasting, underweight, overweight and obesity. Okay, so if you talk about the growth references versus growth standard, growth references describes how children grow in specific population, and growth standard is like describe how children should grow under optimal condition. So you need to understand the difference between growth reference and growth standard. Okay, so now we will talk about WHO Child Growth Standards 2006. These are the standards which are developed using data from children, especially in countries like Brazil, Ghana, India, Norway, Oman and USA. These children were breastfed, they were healthy and raised under favorable conditions. So you can understand that how these standards are developed observing the different children in different countries. Now we will talk about the major growth indicators. Especially in children, when you have to assess the linear growth, the value indicates stunting. Weight for age, it reflects overall growth and the low value indicates underweight. That according to your length and height for age, so it is indicating that you are stunting. Weight for length, height, so it assesses acute malnutrition. The lower value indicates fasting. So your weight, if it is lesser compared to your length and height, then it is showing fasting. BMI for age, it assesses the thinness, overweight and obesity with respect to age and your height. Then there is Z scores. So growth assessment uses standard deviations from the reference population. The Z-score formula is like Z is equal to observed value minus reference median divided by standard deviation. What is the WHO classification which can give the indicators and the cutoffs? If you find that overweight is above plus 2 SD and obesity is above plus 3 SD. So SD is equal to standard deviation, and standard deviation, as we know, is very important indicators towards pointing the nutritional disorders. Now we will talk about the growth monitoring in India. Primarily the programs that are indicated towards the growth monitoring are Poshan Tracker, ICDS program, Rashtriya Bal Swasthya Karyakram, that is RBSK, and this regular growth monitoring program helps in early detection of growth problems and timely action taken by Government of India. Now, the growth chart helps compare a child's measurement with a healthy reference, where versus the Z scores show how far a child's measurement is from the reference medium. An early identification of growth problems ensure the better health and development. So the betterment starts to understand that how it benefits that a growth chart and standards detects early malnutrition. It guides appropriate interventions and supports healthy growth and development of the children. Now we will talk about population versus individual assessment. Why a set of an assessment which is done in the population is having a separate objective, where versus an individual assessment will give a separate objective. Especially anthropometry is used for clinical screening, monitoring the pediatric growth trajectories, or assessing individuals' response to a nutritional intervention. The focus is on precision and clinical cutoff. Here in the picture it can be indicated to see that how the height is measured, the weight is being measured, and even the MUAC. The example is like this is more practically possible to give you the clinical nutrition practice, pediatric growth monitoring, and obesity management. So you may be getting such setup of charts actually when you visit a pediatric clinic, where the characteristics are more highlighted and have a very high precision which is required to give you the exact result. Multiple measurements needs to be done to have a comparison, and clinical interpretation is to be done by a specialist doctors. Now on the either side we will find a population assessment. In a large group of population, the purpose over here is that the objective shifts to estimating the prevalence, tracking the temporal trends, and evaluating the health inequalities. However, the population shifts in the distribution curve are more impactful than targeting the high risk individuals alone. So systematic measurement bias, example using uncalibrated scale across a district, is a more significant threat to validity at this scale than random individual errors. So example are NFHS, CNNS, and district surveys. So you may find that they are very benefiting because they give the characteristics of large sample size, which is more usable to find it, and standardized method, and focus more on prevalence estimation. Now we will understand the key differences of two of this. The key difference over here for individual assessment is like the objective is like diagnosis of the nutritional disorder, and in the population it is more based for surveillance rather than diagnosis. The sample size in individual level is the individual person, where versus in the population it is a large group as a sample size. The precision which is being carried for an individual is very high precision, and you will get more exact result, where for precision if you have to talk about the population it is very moderate. The interpretation for an individual, if the assessment is done at individual level, it is more a clinical assessment, and in the population level it is more an epidemiological assessment. So individual assessment is about helping one person, population assessment is about understanding and improving the health of the communities, which has two different objectives. Now we will talk about the advanced techniques of anthropometric. You will have DXA, that is called as dual energy X-ray absorptiometry. This particular instrument has a different principle where differential attenuation of two X-ray energies to estimate bone mineral content, lean tissue and fat mass, which provides a very regional measures. It is talk about android and genoid. The advantages are high accuracy, regional body composition and bone density assessment. Limitations are it is very expensive, it requires specialized equipment, low dose radiation exposure, the machine variability across manufacturers and software versions, need for very standardization and subject size limitation, hydration affects lean estimates. So, the research application are very extensively in obesity studies, sarcopenia research and osteoporosis studies. So, we will also compare like how the cost and all those will be stated over here. Now, we will go for air displacement plethysmography, that is called as BOPOD. So, it measures the body volume by air displacement and combined by the body mass to compute the body density and derive fat by lean mass via density based equation. The advantage of using the BOPOD is like it is non-invasive, it is very quick, comfortable and suitable for many population including children also. The limitations are it's very expensive, it requires very dedicated facilities, it requires subject cooperation and sensitivity to clothing and hair, especially calibration is very needed. Now the last is bioelectrical impedance analysis, that is called as BIA. The electric current passes through the body, impedance is related to water content and thus fat free mass, single or multiple frequency and single or multiple segment devices. It measures the fat mass, fat free mass and total body water and muscle mass. The advantage is it is highly portable, it is very rapid, affordable, it is very safe and useful in large field studies if standardized. The limitations is like hydration status is important, food intake and physical activity and ambient temperature. So it is more like an individual sort of an assessment. Now we will talk about the comparison of the technique. BMI is in terms of accuracy it is low. For skin fold it is the accuracy is moderate. BIA the moderate to high accuracy. DXA very high accuracy and BOPOD the accuracy is extremely high. In terms of cost, BMI is very low, skin folds very low, BIA is moderate in cost, DXA and BOPOD are very high in cost. The field which is being used is like you may say BMI is excellent and the other like skin fold, BIA, DXA and BOPOD they are good to poor. The key features is like you may say that BMI is simple indirect measure of body composition. Skin fold gives you an estimation about subcutaneous fat and it is operated very differently. BIA estimates about the body water and fat free mass which is very impedance and DXA has a gold standard for body composition which includes a bone density. As you said that the major body volume and accurate about fat and lean estimation, so BOPOD comes as a good valuable way to take this measurement. So the choice of the techniques that are being stated is depending on the goal of the population, the resources and the required precision. So what you need to do, you have to define the objectives, you should know the population whom you are measuring it and you are considering the resources and the constraints for the cost. And you ensure the standardization, so there is no such as a single method that can be stated that it is perfect or it is having a strength. So you need to understand the interpretation and application for the same. Now the obesity paradox in epidemiological studies. Obesity paradox refers to the observation that an overweight or mildly obese individual sometimes appear to have a lower mortality than individuals with normal BMI in certain population. So you may say that a person who is lesser with 18.5 as a BMI is underweight, where 18.5 to 24.9 is normal and above 25 and below 30 it is overweight and above 30 it is obese. So what are the examples? Observed examples are older adults, you may have heart failure patients, you may have a chronic renal failure patient and certain cancer population. The proposed explanation is that reverse causation. The disease itself on the subclinical ground cause weight loss prior to the diagnosis. So the normal weight category may thus contain individuals who are actively ill and looking like losing their mass. So inflating the mortality rate for that group. Then comes the second, that only healthier obese individuals survive long enough to be included in the study. That is survival bias. Measurement errors. BMI is inadequately measures body composition. So BMI does not differentiate between protective muscle mass and harmful visceral fat. So you can understand like how older adult must have higher BMI, might have higher more chances. Then comes the protective energy reserves. So extra body reserves may provide advantage during severe illnesses like surgical recovery, infection and chronic diseases. Confounding factors, okay, with cigarettes, lower BMI and higher mortality risk. So smoking is a classical confounder. It suppresses the appetite leading to lower BMI but drastically increases the mortality risk. So why does the body try to see that obesity paradox matters? The obesity paradox highlights the limitation of relying solely on BMI. So it reminds us to interpret that epidemiological findings critically and consider underlying the mechanism. So what researchers should consider? The researcher should consider on weight circumference, body composition, physical fitness, metabolic health and disease severity and other risk factors. A comprehensive assessment beyond BMI leads to better risk stratification and improved health outcomes. Now we will discuss the case measuring the obesity in India, and are we really measuring it correctly is the big question over here. So we are differentiating between an urban district and a rural district. In the urban district there is a high risk of IT job, sedentary lifestyle and high obesity and diabetes. In the rural district there is an agricultural laborers, high physical activity, low healthcare access, undernutrition plus obesity. We are comparing and we are using weight, height, BMI, waist circumference and skin fold thickness. Now the survival protocol is like weight, there are portable digital scale, height, portable stadiometer, waist circumference by flexible tape and skin fold we are using by tricep and subscapular using calipers. We have taken the sample of 500 each from the rural and urban and the results are indicated over here. The results showing that the mean BMI was 27.4 in urban, which is indicating towards obesity. In the rural it is 21.8, so it is in a moderate. Obesity like here in the urban was seen by 36% in high, where the rural population it was 9%. The mean waist in centimeters is 95, where versus on the rural side it is 81, which is indicating that there is a centralized obesity. High risk waist, that is 42%, and in the rural it was 14%, which was lower part. The mean skin fold was 24 here, where versus there it was 14. So what is the indicator? Obesity is primarily an urban problem and it requires intervention only in urban areas. Now this case discusses one very important question, that is this conclusion justified? Initial interpretation, higher BMI, abdominal obesity, body fat in urban population seems reasonable, but let's go into the deeper. The strength is that when you talk about the urban survey, better infrastructure, indoor measurement, easier equipment are used and better literacy and cooperation is done, so you will get a good survey over here. But the weaknesses is like selection bias, weekday sampling and fitness misclassification, like people who are having muscular, they have a high BMI. Where versus in the rural you will have a very critical approval. Environmental challenges, you will not be able to go over there, your low literacy, the compliance is very poor, transport and equipment through road, tough roads, calibration issues are very much, and observation issues are very inconsistent. So comparing urban and rural findings is something like lower physical activity is more towards the urban population, more processed food, sedentary behavior and higher obesity risk. Where versus in the rural it is not being seen. So you could have measured higher errors, weight errors also and waist error. So skin fold errors are also biases. So additional rural reality is something very different. In rural reality, there is a double burden of malnutrition. So obesity is increasing in rural India too. Why? The reason is like undernutrition, like stunting, micronutrient deficiencies with additional overnutrition, which is more pointing towards obesity, diabetes and hypertension. So what is the conclusion for this case study? It is like good data is equal to good method, protocols versus assumptions, and don't rely only on BMI alone. You should also additionally try to have association of measuring it carefully as a waist circumference, interpret the results very critically and act very wisely, and then you can see the improved health. So with this we come and end to this chapter of anthropometric measurement, which is a very systematic assessment of body size, shape and composition used to evaluate the nutritional statuses, growth and health risk. So the common indicators such as BMI, waist circumference and skin fold thickness helps us to identify the undernutrition, overweight, obesity and body fat distribution. Growth charts and standards are essential for monitoring child growth and detecting the malnutrition. While we take anthropometry, which is very inexpensive and practical for large population surveys, and country like India should always try to use this, but accuracy in terms of measurement requires standardized protocol and trained personnel, which is a very important task. Advanced techniques such as DXA, BotPod and bioelectrical impedance analysis provides a more precise, very highly valuable and body composition assessment, but the cost is something which is putting it on the other side. In epidemiological research, anthropometric measurements are very fundamental tools and they are being used for understanding the population's health and informing that nutrition and public intervention programs. So with this we come into this chapter. These are very important references that you can use to deeply study this topic. Thank you very much.